So yeah, there we are, the chain rule. Wait, what? Never start chain smoking? Always lock your bike with a chain? Bouncers need to have at least 10 gold chains? Almost correct. So let's first take a look at this function, 2x plus 1 squared. Okay, some of you will notice we can also find the derivative with those things we've learned so far. First, we multiply, you know, the first binomial formula and all that. This leads to 4x squared plus 4x plus 1. You all know how to differentiate this. Just press pause quickly if you want to do so. The result is 8x plus 4. So far, so good. However, now we could also think, multiplying all that out is just a hassle. Can't I simply differentiate this right away and do it the way I learned before? So we take the exponent and put it in front of the bracket, reduce it by 1, and what does it give us? 4x plus 2. Shit, that's not the same as we got before. So I can't do it this way and still need to multiply all this out? Nope, you don't. But there's still something missing, the chain rule. The beginning was correct, so we can rewrite this real quick. However, we also need to take the inside derivative. What's that? All that jazz within the brackets? This first needs to be differentiated separately. The derivative of 2x plus 1 is 2. Because that thing is located within the brackets, it's called the inside derivative. And that is simply multiplied with all that at the end. Would you look at that? Now we have the right answer. So right off the bat, another example. An example where you won't even think of multiplying things out. 2x minus 3 to the power of 10. So if we can't multiply it all out, why not use the chain rule? Step by step. First, we find the derivative of that stuff outside. For this, we move the exponent to the front, so that means 10 times the brackets. Then, we make all this one smaller. So let's just put this here. Now, important, we do the inside differentiation. That's this part here, which is also 2 here. We multiply by this at the end, and all done. So what exactly does the chain rule do? To answer this, let's have another look at the example we just did. Here, you calculate the value of the function in 2 steps. First, you calculate 2x minus 3, and then you take all that rubbish to the power of 10. So you practically have a function within another function. The inside function is 2x minus 3, and the outside function, that stuff, to the power of 10. As the functions form a chain of functions, all this is called the chain rule. The chain rule always follows these steps. First, you differentiate the outside function as if it were just an ordinary variable. Inside the brackets, all that stuff stays well within the brackets. So the brackets to the power of 10 turns into 10 times the brackets to the power of 9. And now you guys will find the derivative of the inside function. In this case, 2x minus 3 simply turns into 2, and those two derivatives are multiplied. Of course, this doesn't just work for regular exponents. How about the sine of x squared, for example? Here we reach that point again, where multiplying it all out just doesn't cut it. We really need the chain rule. Always in good order. Search the outside function. That would be the sign before the brackets. First, we differentiate this. So the sign of the brackets turns into a cosine. And then there's the inside function. That's that x squared, so the derivative is 2x. Now we multiply both, and Bob's your uncle. That's the derivative of the function. One more thing, don't let it confuse you. The inside function is often given its own name. So you could simply call the x squared the v of x. Of course, it really doesn't matter what you call it. You often see people use g of x. You can do whatever you like. Meanwhile, the outside function is still waiting for its name, u. And instead of 3 points, we can now also write the u of v is sin of v. Because in the function, we see sin of x squared, and that's simply v. Now for the chain rule, differentiate both. First, the outside function, the derivative of u of v is the sine of v derivative, so the cosine of v. Then, the inside function. V derivative is x squared derivative, so 2x. Now we multiply both derivatives. Pay close attention. This is where that completely wacky equation comes from that you just might have seen before. F prime of x equals the derivative of u of v times the derivative of v. So, the derivative is, following the chain rule, the cosine of v times 2x. And to get rid of that silly v again, we replace it by x squared again. And here at the top, we write v of x, as v is dependent on x. And that's our chain rule. Alrighty then, what should you remember? You need the chain rule for chain functions. In this case, first find the derivative of the outside part, as if the inside part would be nothing more than a plain and ordinary variable. Then, you differentiate the inside function. Just do it on the side real quick. Then, you multiply both things by each other. And there you have it, the derivative using the chain rule. We often give both functions names such as u and v. This makes the chain rule look a bit more complicated, but it's all the same in the end. Perfect, we've checked the boxes. On to the next videos.